Hey, what's up? I'm Nishit Tarantula, and this is my video on trigonometry. So, what is trigonometry? Trigonometry is a branch of mathematics that deals with the study of a right triangle. Let's study this name deeply. Trigonometry is made up of three Greek words: tri, gono, and metry. Tri means three, gono means side, and metry, which is derived from the Greek word metron, means measurement. So this suggests that trigonometry is a branch of mathematics that deals with the study of a polygon with three sides. Study with the measurement of a polygon with three sides. That polygon is nothing but a right angle triangle. When I say right angle triangle, this equation must come in your mind. C square equals a square plus b square. This is the Pythagoras Theorem. It says that the square of the side hypotenuse, which we call hypotenuse AC, is equals to the sum of the square of sides AB and side BC. That is the sum of square of side adjacent and perpendicular. So how trigonometry helps us to study this right triangle. Trigonometry provides us with trigonometric ratios. There are total 6 trigonometric ratios, but 3 are the main, so we'll first start with the first main 3 trigonometric ratios. First of all, what are ratios? Ratios are basically used to compare two entities. Suppose, let's say, there is a rectangle. This is the breadth, this is the length. Let's say the length is 2 times its breadth, so there's a ratio of 2:1 between the length and the breadth. There's a ratio of 2:1. So if I have to construct a whiteboard, let's say, if I have to construct a whiteboard with the same ratio, 2:1, I can simply do it. Let's say the breadth is 2 units and the length is 4 units, is still in the ratio 2:1, because 4 by 2 is 2 by 1, that's 2:1. So we can say that both the two rectangles are in the same ratio. That means there's a relation between these two rectangles. There's a relation between the length and the breadth of this rectangle, and there's the same relation applied here with the length and the breadth. So we know what a ratio is. It's used to compare two entities. So what are trigonometric ratios, also known as trig ratios or t ratios or trig functions? So we have 3 major trigonometric ratios. First is sine, second is cosine, third is tangent. These 3 are the main, and the other 3 are cosecant, secant, and cotangent. Let's focus on these 3 first. Sine. Sine, mathematically, it's written as sine of angle theta. Let's say this is angle theta. Sine of angle theta is equals to the opposite of theta, which is AB, over hypotenuse, that's AC. Now we can say that sine of angle theta is equals to AB over AC, that is, it's equal to the opposite over the hypotenuse. Now let's see the cosine. It's written as cos theta, which is equals to the adjacent is this BC. We have to see in respect of the angle, so with respect to this angle, the adjacent is BC. So cos theta is equals to BC over the hypotenuse, which is AC. Now tangent. It's written as tan theta, which is equals to the opposite, which is AB, over the adjacent, which is BC. Now you'll say, there are total 6 trigonometric ratios. How can one remember each each identities? Well, there's a trick. I saw it somewhere, basically. The trick is SOHCAHTOA. This is a funny trick. SOHCAHTOA. It helps us to remember these first three trigonometric ratios: sine, cosine, and tangent. So sine theta is equals to opposite over hypotenuse. Cos theta is equals to the adjacent over hypotenuse, and tan theta is equals to the opposite over adjacent. So if you just remember SOHCAHTOA, you'll just recall these three trigonometric identities. So let me recall it once more. Sine of angle theta is opposite over hypotenuse. Cos of angle theta is adjacent over hypotenuse, and tan of angle theta is opposite over adjacent. What about these three trigonometric ratios? It's so easy. Cosecant, which is written as cosec theta, is nothing but the reciprocal of sine theta. So we know that sine theta is AB over AC, so it will be, which is equals to AC over AB. Therefore, we can say that cosec theta is equals to AC over AB. So here, let's say, if on the cosec theta, it will be equals to the hypotenuse over the opposite. It's just the reciprocal of sine theta. Cosec theta is the reciprocal of sine theta. Now let's focus on secant. It's written as sec theta. It's the reciprocal of cos theta. So it will be AC over BC. Now cotangent, it's written as cot theta. It's the reciprocal of tan theta, which is BC over AB. Hope you have remembered these. Hope you have understood these six trigonometric ratios. Now we'll move on solving some problems and deriving some trigonometric identities. Now let's solve a problem. You're given a right triangle with side AB equals 2 units, BC equals 4 units, and therefore AC is equals to 2 root 5 units. So we want you to find the sine of angle alpha. We know that sine theta is equals to opposite over hypotenuse, so sine of angle alpha, this angle alpha will be opposite, which is BC over hypotenuse AC, which will be BC is 4 over AC, which is 2 root 5. We'll get 2 over root 5. Now let's use the rationalization method. Multiplied by root 5 over root 5, it will be 2 root 5 over 5. So sine of angle alpha in this case is 2 root 5 over 5. Let's find out cosine of angle alpha. We know that cos theta is adjacent over hypotenuse, so cosine of angle alpha will be the adjacent side, which is AB over AC, which is the hypotenuse. So it will be 2 over 2 root 5. Cancel 2, we'll get 1 over root 5. This is the answer. Cosine of angle alpha is 1 over root 5. If you want, you can rationalize it. It will be root 5 over 5. Now let's find the tangent of angle alpha. We know that tangent is equals to opposite, which is BC, over the adjacent AB. So it will be 4 over 2, that's 2. So the tangent of angle alpha is 2. Now if I say you to find out the cosecant of alpha, cosec alpha, it will be the reciprocal of sine alpha, because we know that sine theta is the reciprocal of cos theta, and cosine theta, and cosine theta is the reciprocal of sine theta. So if sine alpha is 2 root 5 over 5, so cosine alpha will be 5 over 2 root 5, and so cos theta is root 5 over 5, so secant alpha will be 5 over root 5. and if tan alpha is 2, so cotangent of angle alpha will be 1 by 2. So this is so easy. Now let's check one thing. What is sine theta over cos theta? What is sine theta over cos theta? This is our identity number 1. Let's check. I've made a right triangle here with this angle theta. Sine theta is the opposite, which is AB, over the hypotenuse AC, over cos theta, which is adjacent, which is BC, over the hypotenuse AC. Now if you use simple algebra to calculate, we'll have AB over AC times AC over BC, because AB by AC is getting divided by BC over AC, so it can be written as in this way if you know simple algebra. AC and AC will be cancelled, therefore we can say sine theta over cos theta is AB over BC. What is AB? AB is the opposite, and what's BC? BC is the adjacent of angle theta. But we know that tan theta is equals to the opposite, which is AB, over the adjacent, which is BC, and this is the same thing. Therefore we can say that tan theta is equals to sine theta over cos theta. This is our first identity. This is very useful. Yeah, I need to tell you one thing. Every time if there's a particular equation, so every time if the angle is given theta or something else, alpha, beta, a, b, c, anything else, so the value of the similar angles will always be same. Suppose here if theta is 36 degrees, so here also theta must be 36 degrees in each. So this is our first identity, that tan theta is equal to sine theta over cos theta. So this was all in the part 1 of the my video on trigonometry. So in the part 2 we will discuss more about trigonometry, and we'll also derive some more trigonometric identities, and then further we'll use trigonometry into real life. So that's all for today. Thank you. Bye. Have a nice day. Yeah.